What's up, everyone? It's Miss Wesley, and I want to know who is ready to take it to the limit today. We're looking at limits packet, page 2. We had already spoke of times that limits do exist and don't exist on a graph, and I want to be very visual today. Most of the problems you see today, you'll have a picture in front of you and you'll interpret limits based off of it. But there is a little bit of notation we probably need to nail down first. Limits, we've spoken of a limit. Limit as x approaches c of f of x means that you're assuming the graph is approaching that limit from both sides. Well, there's a way to split that up notation-wise, and sometimes it's important to speak of left-hand limits versus right-hand limits. And you'll see the one difference is the superscript, the plus or the minus after that c in those examples. And I want to define these. Okay, so a limit as x approaches c with the negative superscript is going to be the limit as x goes to c, so as x approaches c from the left. That's important. I'll put that in all caps, from the left. And I am going to write just about the exact same phrase, but with the opposite direction for this plus superscript. So this second one is going to be the limit as x approaches c from the right. And we'll see this in play in the graph below. The limit only exists. This is so crucial. A limit is only going to exist technically if and only if the limit from the left of c, so x approaches c with a little negative sign, is the same thing, equals the limit as x approaches c from the right. So those two one-sided limits must agree for there to be a limit as a whole. Try this warm up on your own. See what you think. Try to interpret, like for the very first one with the new notation with the little negative superscript. That doesn't mean 2 from both sides. As x goes to 2, look on the graph. As x approaches 2 from the left, what y value looks like the graph is approaching. And I would say 2 there. So I was going to say, feel free to pause, try A through I, tune back in. Let's check answers with each other. Okay, I'm going to keep going right here. Picture the same analogy I was using in previous lessons. You've got a guy walking up a function this way. You've got a guy walking down a function from the right that way. Well, this is a happy story. These guys are going to meet. From the left of 2, as x gets closer and closer to 2, y approaches 2. From the right of 2, y is also approaching that same hole. Yeah, I know there's a little phantom point up here, the point 26, which actually will come into play as f of 2 later down the road. But if you're just speaking about a limit at 2, you care about just that little neighborhood around the function, regardless of where that filled in dot may be. So to summarize, I'm going to say the left-handed limit is 2, the right side limit is also 2, and if these two answers match up, right, if 2 from the left and 2 from the right give you the same value, you can say the limit is 2 as a whole. F of 2 is going to be the closed-in dot there, right? So the closed-in dot is going to be 6. Now we've got a series of questions about the x value 4, and I notice visually it's like a dead giveaway. There's a big gap on the graph, so I'm feeling like there might not be an answer to G, but I'm getting ahead of myself. Are there left and right-hand limits? Well, in E, limit as the function approach, so x approaches 4 from the left, it's like you're walking up the function and you need to stop yourself when you get to that x value, when you get to 4. You can't jump down. So from the left, you're up at the y value 5. I'm going to make that my answer to part E. From the right, well, start as far right as you can go, slide along the function. You have to stop once you've hit that x value 4. So from the right, you're only down at 3. And here's your classic case of these two values not being equal, leaving you with nothing to put as an answer for G. So it does not exist. Is there an f of 4? Well, look at the graph and answer this how you would have answered it in an algebra or Precalc class, right? Your closed-in dot at 4 or your actual value of the graph at 4 is going to be 5. It matches up with that left side limit. How about 8? This one does not have a superscript after it. When that happens, you're assuming that you're being asked for the limit from both sides of 8. So if they agree, maybe we could put something to describe the behavior of the function. Well, from the left of 8 and from the right of 8. Could a safe answer be does not exist? And we'll go over this. We're going to refresh this a little later in the lesson, but that is the safest answer. If you visually see a big VA at the desired x value, I guess I got to move myself. Then safest way to answer it is a limit never really does exist at a vertical asymptote. So DNE is acceptable. I guess in this case, since the behavior matches on both sides, the two gentlemen walking down the function would be walking the same way. And we could also correctly answer this with a negative infinity, okay? If you thought that was fun, let's try some others. Again, as we get to each one of these, feel free to pause, make your own decisions first, tune back in. Let's see if you and I can come to some agreements. All right, limit as x approaches 0. There's no superscript after it. It's assuming from both sides. So from both sides of 0, I feel like there's no funny business going on. They're kind of just meeting up at 2. So there's a limit there. There's a function value there. They call that in calculus a continuous portion of the function. No skips or gaps. 3 from the left, 3 from the right. So 3 from the left, let me start from the left and stop when I get to x equals 3. We're up at 4. 3 from the right, start from the right, stop when you get up to the x value 3. Your y value is going to be 2 down there. And common follow-up, is there a limit for 3 from both sides? Well, no, because b and c were not the same answer. So a dne for that one. And f of 3, function value. Do I pick that or that? No, I'm not going to pick open dots. Your closed-in function value is going to be the y value 3. Okay, whoa, count them. What's 12 different questions all about the same picture, and a little bit of controversy going on here, but again, feel free to pause and try these on your own. I'm gonna go 4 at a time. So the first 4 questions are all concerning the x value -2. So -2 from the left. Let me just travel from the left and stop. And it looks like, can you see that these, the graph's a little tricky? It's counting so that every tick mark is only half a unit. So I'm going to say the y value being approached from the left of this x value is going to be -1. Okay. How about from the right? Slide along the function, stop when you get to the desired x value, -2 from the right, and it should be up at +1. That helps me be a little more confident when I answer part C. It's still the limit as x approaches -2, but from both sides, and those 2 answers didn't match up. So the limit does not exist. Is there an f of 2? Sometimes there is, sometimes there isn't. I say closed-in dot at that part of the graph. So we're going to say f of 2 is 1. Okay. All right, now next 4. They're all about +2. Can you move yourself over to this area of the graph? Real quick visual. From the left side, limit's going to be 1. From the right side, limit's not 1, limit's going to be 2. There's a gap there. So like we would have predicted, because of that jump, left and right side limits don't agree. We get another big dne. And how about f of 2? Is there an f of 2? Yeah, closed-in dot up at 2. Okay. 2 questions about 4. 4 from the right and 4 from the left. This one might be the most controversial. It's hard to draw an infinite oscillation here. It's actually impossible to draw an infinite oscillation. So if these dotted lines, that's what I took it to mean. Bottom line, I said does not exist for the limit as x approaches 4 from the right, because I thought that whoever drew this graph was meaning to indicate that there's an infinite amount of oscillation there. We went over how as you're getting closer and closer to that x value -4 from the right, it's just bouncing this indefinite amount of times between 2 fixed values. If you had just considered this a solid line and had told me the limit were 2 from the right, I don't think I could fault you for that, because you can't really adequately draw an infinite oscillation. But I'm going to go with dne. From the left, there's no oscillation there. I'll say the answer is going to be 2. And to me, I say there's no limit as a whole. If the follow-up question were what's the limit as x approaches 4 period, I'd say nothing, since I didn't get an answer to I. Let me just circle that one as our controversial question. F of 0, I could not find. I looked up and down, and all I could find was an open dot at the origin. So I'm going to say undefined. You'll see sometimes on my answer keys a mixture between my undefineds, my empty sets, and my dnes. You can write either. Undefined and dne, same exact thing. Generally, on my keys, if a limit doesn't exist, you'll see that acronym, dne, on my key. If a function value doesn't exist, you'll see that abbreviation UND for undefined. But again, interchangeable in my book. Letter L, x approaches 0. There's no superscript after it. It's assumed from both sides. Luckily, both sides seem to match up. 2 people would slide together at this function at the origin. So although there's no function value there, here's a case where there is a limit at that x value. Okay, what is in store for us on the next page? Looks like number 3 is a good one. It's a graph with a bunch of vertical asymptotes. That's a heads up to me. I bet you there will be numerous times in this one where the limit is not going to exist. Limits don't exist list at VAs. In fact, for any questions, maybe besides the first one, besides part A, I bet you that DNE might be a safe answer for all the questions about 0, because it seems like there's an asymptote there, and for the question about 4. Let's see if we can do better than that. Can we be a little bit more specific about the behavior of the graph? So for part A, nothing really weird going on at -6, right? That's this point here. People coming up and down the function to meet each other would meet at that y value 0. So nothing really too crazy with that first one. Then we start talking about 0. Again, you can put DNE for all these answers, and that actually gets you full credit. Even on an AP test, that would give you full credit for those 4. But can we do better? 0 from the left looks like we're growing forever. We could say positive infinity. 0 from the right looks like we're falling forever, so we'll say negative infinity. And that just prohibits us from getting any kind of description for D. We can say DNE, because even the 2 types of infinity aren't agreeing from the 2 sides. As opposed to part E, right? Limit as x approaches 4 from both sides. There is no limit, right? The function is going to decrease without bound from both sides. However, the 2 sides do match up. So both are approaching negative infinity, which is a bit more descriptive than just putting does not exist. Okay, have you had enough yet? Let's look at one more graph. So 4, we've got, wow, limit as x approaches 1 from both sides. So 1, let's just get my bearings here. It looks like from both sides you're growing to the y value 3 there. I'm going to say 3 for the first one. Again, feel free to pause and try these, but I'm going to go in for 3 from the left and 3 from the right. So 3 from the left, I'm going to say 2. 3 from the right, I'm going to go down and say -2. And 3 as a whole, I'm seeing this pattern here where we get it does not exist at that jump. F of 3, don't pick either one of these open dot y values. Pick the one that's closed in. Pick 1 for f of 3. X approaches -2 from the left, -2 from the left, -2 from the right. The limit as a whole, that should all be -1 here. Again, we're counting by 2's. So -1 I'm going to say, -1 again. And if they ask me for it with no superscript afterwards, I can be confident and say -1 again. Last but not least, f of -2. This one's also hard to catch. Way down here at -3, you see a closed-in dot. Okay, now we've got my favorite types of questions. With those ones, it was good just to get our feet wet with interpreting a graph, but now I want to be creative and sketch my own graph that meets all of these conditions. A good strategy for number 5 is if you see any conditions that can be met easily, quickly first, just get them out of the way. F of 2 equals 1. Let's just check that off the list and put a closed-in dot at 2, 1. F of 0 is undefined seems like it won't be that bad to depict, but why don't we save it for the end and maybe work in pencil here so that if I have to erase or get rid of something, I could just make sure that I have no filled in point or value at x equals 0. Okay, so here goes, going in order. We've got 2 requirements about 0, 0 from the left and 0 from the right. Limit as x approaches 0 from the left equals 1. So can we do that? What I'm going to do is I'm going to put an open dot just to be safe. Open dots are safer than closed dots because they prevent you from accidentally breaking the vertical line test. And also I've got this kind of lurking in the back of my mind that I want f of 0 to be undefined. So 0 from the left equals 1. Let me put an open dot at this x value and this y value, 0, 1. I want the function to approach it from the left. I don't care how much of a graph you draw here. It could be a little curve or a squiggle or whatever you'd like to draw, but I want this graph to approach it from the left, and I can check off that requirement. Okay, limit as x approaches 0 from the right is -1. Try the same strategy. Open dot at 0, -1. It's a good thing we made these open because we don't want to fail the vertical line test. And I'm just going to draw a little tiny bit so that it can be approaching that from the right. So let me just do that, right? I don't want to go too far. I don't want to fail the vertical line test. I want to approach that from the right. Limit as x approaches 2 from the left equals 0. Ooh, okay, so I already have a closed-in dot here. Let me put an open dot at this x and that y at 2, 0. And you know the easiest thing might be to do is just connect the line there. I mean, you don't have to, but that kind of kills 2 birds with 1 stone, and it helps you meet both of those requirements. One more to go, and then we got to make sure this one's taken care of. X approaches 2 from the right equals 1. Well, what do you know? I already have a closed-in dot at 2, 1. So why don't I go like this, have it attached there, I'll just draw arrows on the ends. And because of my open dots here, I've actually already met that final requirement, right? If for some reason I had closed in a dot by accident, now would be a good time to erase. There's another good example underneath. I hope you enjoy the rest of your day, and I'll talk to you very soon.